94.8 milliliters of 0.1811 molar potassium chloride solution and mix it with some milliliters of lead 2 nitrate solution, how many grams of lead 2 chloride can be formed? So this question screams limiting reactant problem. So I'm going to put LR up here. And we know that it's a limiting reactant problem because if I take my volume and my molarity, I can find moles of potassium chloride. And I can do the same thing for my lead 2 nitrate. Anytime you can find moles of two reactants, it's a limiting reactant problem. And I'm just going to write that. Anytime you can find moles of two reactants, anytime you can find moles of two reactants, it is a limiting reactant problem. And so limiting reactant problem means, of course, you do have to find both moles of reactants and then work all the way across to what we call stoichiometry to find the moles and then the grams of product that can be formed. Whichever one is the smaller amount of moles, that is the amount of moles or grams that you can actually make. Now my process for this is I'll start with my potassium chloride. I will convert my milliliters into liters by moving my decimal point 3 places to the left. I get 0.0948. I'll zoom in a little. There we go. Liters. This is going to be a long stoichiometry or a long picket fence type problem. I have my liters. I have my molarity. I'm going to write molarity out as moles per liter, so 0.811 moles of potassium chloride. Per 1 liter. And this is the molarity. From there, I know now my liters cancel, so I have units of moles of potassium chloride. It'll be 2 moles of potassium chloride for every 1 mole of lead 2 chloride. And this middle step, or this second step, is called my mole-to-mole conversion. And it always uses coefficients from the balanced reaction. And anytime you have a balanced reaction, chances are you're going to need to do this. Now I have moles of lead chloride, lead 2 chloride, and I want grams of lead 2 chloride. So I need the molar mass. I look it up on my periodic table. I find out that 1 mole of PbCl2 is 278.1 grams. And I don't know if I have enough space to actually write the number over there, but I'm ready to set up my equal sign and write it. Let's go ahead and do that. I have 0.0948 times 0.811 divided by 2 times 278.1, and I get 10.69 grams of lead 2 chloride. And I can further say that this is the grams of lead 2 chloride if potassium chloride is the limiting reactant. So that's my note that that's true if potassium chloride is limiting reactant. Now I have to do the other one. Let's see. So I have 69.9 milliliters, which I convert into 0.0699 liters. And I'm going to be doing the same type of thing again, so I'll make a nice long picket fence. And now my molarity is 0.729, and that's going to be moles of lead to nitrate per liter. Now it's a 1-to-1 ratio. I hope I have enough room. And my last step in this particular case is going to be the same as my last step up here. And you can see we're getting quite extensive sets of calculations here for problems. Hopefully you feel like we're building this up step by step so you're ready for it. And now let's multiply this part out. 0.0699 times 0.729 times and divided by 1, so we don't have to do anything there, times 278.1. I get 14.2 grams, which I think 3 sig figs is plenty. I'm not sure why I went to 4 sig figs there. And we can write 14.2 grams of lead 2 chloride if lead 2 nitrate is the limiting reactant. And we know that it's always the smaller amount that we can make, because at that point we'll run out of our potassium chloride and we cannot make any more. That's why it's the 10.69. Or the 10.7, I should say. 10.7 grams is what we would enter for this question. So let me show the question. Any questions about this? Happy to take them.